Now we're going to use Snell's law. We're going to do two separate situations. We're going to find the index of refraction, and then for our second situation we're going to find the angle, the theta. So for situation one, you're going to have some question written out, but generally what you're going to be told is, okay, you have some sort of material that has some sort of index of refraction, and you're going to be told that a ray of light comes in at a certain angle. So there's your incoming angle. There is your normal to that angle, and it is going to be coming in at 40 degrees. I'm going to tell you that your N1, which is on the outside, so this N value is going to be 1.21, and what we'd like to do is find that N value. Okay? And what we'd like, I guess we need to have a little bit more. We're going to tell you that this thing is going to bend or refract into that substance at 35 degrees. We'd like to find our unknown N. So let's write down Snell's law. Snell's law says that you can go N2 over N1, and then what you have to do is you have to do the reverse of the signs. So if it's N2 on top, then you're going to go sine of theta 1 over sine of theta 2. Okay, that's Snell's law. What we'll do is we'll plug in the values we know. Well, we need to identify a 1 and a 2 side, so I'm going to call this side 1 and this side 2. So my N2 then will be the unknown. My N1 would be 1.21. My sine of theta 1 is my one side, sine of 40. And that would be sine of 35. There. Now it's set up, and all we have to do is solve for N2. So I'm going to cross multiply that, and I'm going to get N2 equals 1.21 sine of 40 over sine of 35. Plug all this into your calculator, and you get an N2 value of 1.35. So that means this is 1.35. That's the index of refraction for this material here that the light is refracted into. So if you look, it comes in at, it comes in at 40, and then it refracts to 35, so it's bending towards a normal, and we know that when you go from a smaller index of refraction to a bigger one, that it's supposed to bend towards a normal, so we're okay here. If you extend this, and then we make a normal, well, this one's coming in at 35, and if we want to figure out what it comes out at, your angle that it comes in at from index 1, it's going back out to index 1 again, so this, without any work, you just know that that's 40 degrees. Okay, that was situation 1. Situation 2 is going to be where we again are going to have some material. So here is our material again. This time I'll just draw my ray of light coming this way. So here is my ray of light. There is my normal. This time I'm not going to know what angle it's going to be coming in at, but I'm going to tell you that it's going to refract off at 53 degrees. I'll also tell you that this N on the outside of the material is 1.4, and the N for the inside of the material is going to be 1.7. So you're going from smaller N to bigger N, so you know that this thing should be bending towards, which means that 53 should be smaller than whatever you find here. We're going to verify it. So this time, previously I went N2 over N1. This time I'm just going to randomly reverse them. N1 over N2, sine theta 2 over sine of theta 1. Okay, I'm going to fill this thing in. My N1, this is my one side, this is my two side. My N1 is 1.4, my N2 is 1.7. My sine of theta 2 is sine of 53, and this is sine of, I guess, theta 1. That's what I'm trying to find. What I want to do is rearrange this thing to get sine theta 1 by itself. So first thing I'm going to do is I'm going to switch these two positions, and then I'm going to cross multiply my 1.7, and that's going to come up here. And what that does is that gives me sine of theta 1 is equal to 1.7 sine of 53, right? The 1.7 comes across, and then the 1.4 comes to the bottom. Plugging that in, Don't do it all in one step. Just tell me what this decimal is first. You should end up getting 0.969. Now you're going to hit second function on your calculator. Second function sign 0.969, and you're going to get a theta 1 value of 75.8 degrees, which you could probably get away with just rounding that up to 76. There you go. That's your two ways of using Snell's law. Finding the n, finding the theta. There you go.